Okay, this video clip is about a washing machine, real washing machine electronic control water valve, some measurements, and trying to take the model of the circuit in the electronic environment. So the safety is first. There are some high voltages involved in this experiment, so you should be very cautious, and you should not perform these unless you're a certified electrician. What is this water valve thing? That's washing machine. In ordinary washing machines, there are water valves. Those are electrical and electric controlled. There's an electromagnet for control, and this is the water line. This is the inlet. This is outlets, and in between, inside, there's an opening or closing for the water passage. So we remove the water part and concentrate on the electrical part. The electrical part is an electromagnet with magnetic circuit here. So that's a kind of ordinary steel circuit, and internally it's forming the magnetic circuit. This wire is added by myself. This is a 3-turn wire across that magnetic circuit of one leg. So you should think of its role in this circuit. Normally, this wire does not exist. So when 220 volts excitation is applied to the coil, it forms a magnetic flux inside. That flux pulls the internal ferromagnetic material to open the gate for water transfer. Let's have some measurements on this device, ignoring my added 3-turn wire. So here's our device. It can measure inductance, resistance, as well as capacitance. So we use the inductance measurement first. We connect the main circuit of the electromagnet and turn on the device. So this setting, this blue button, should be pressed out for inductance. We have 91 millihenry inductance as measured. Next, we'll measure the resistance. But in order to measure the resistance, we have to select the terminal pair suitable for resistance measurement. So again, after suitable connections, we measure around 103 ohms resistance. So these are the two measurements obtained for the wire. Now, there are some questions. That L, that R, my question, what's the number of turns in the main coil? This cannot be known from outside by just looking, but indirectly we can have an idea. So that's the okay, in order to measure N, and I will not give the details because you are supposed to find the details. So if I apply 220 volts here, this will act like a transformer, and this is like a secondary. And we can measure the AC voltage, it should be very low because of the low number of turns. And this is an AC measurement. So there's no connection at this moment. So it's just measuring some noise. We connect to the terminals. Yes. And now this is the dangerous part. Do not do these kind of things at home. So 220 volts will be applied by our plug at the outlet. So when we, okay, now we have about 17 millivolts. Factor. So N1 is N1 or N primary is unknown, and secondary is 3. So this V1 is actually V out is V2. V1 is 220 volts RMS. So by given these parameters, what's the number of turns in the primary? What's the reluctance of the electromagnet or the coil? And these are the things to be solved.